So I've opened up a fresh Python REPL, and I'm going to create a list. I'm going to create something very similar to a list. I'm going to create another something very similar to a list. And now we're going to do type on all three of these. Now, you can see this first one is a list, the one that I use, square brackets for. The one with parentheses is called a tuple. Some people say tuple. And then the third one with curly braces is called a set. Okay, now to understand what the difference between all these is, you can do dir on list, dir on tuple, and then dir on set. And you'll notice, hopefully right away, that the list functions are this long. There are this many of them. But for tuple, there's only two. There's only count and index. And then for set, there's quite a few more. So they're pretty much all different things, all different constructs that can hold kind of the same things. But we'll see that tuple is actually, it's called an immutable data structure. So once you create it, you cannot change it. Once you create a tuple, you cannot change it in any way. So, B is my tuple. If I try to do b dot append, I can't do that. And I can't even access, I think I can I can access the first item there, or the item at index 1, but I cannot change it. I can't reassign it. So tuple object does not support item assignment. So once you create a tuple, you cannot change it. That seems a little silly. Like, why would I ever use that? A list does way more. But you'll find tuples in the wild, especially from return statements. You'll see those quite a bit. I think they're super cool because Python has this really neat sort of intermediate feature called tuple unpacking. Tuple unpacking is really swell, so you should check that out on your free time. The set is sort of like a tuple, sort of like a list, but it's unordered, and it does not allow for repeats. So let's look at C. And if I tried to do, let's see, instead of append, it's add, because I'm adding it to the set. If I tried to add 3, it would just be exactly the same. So it won't take duplicates. But if I tried to add 0, it won't add it to the end. It's going to add it to the beginning, because it's it orders it in its representation, but deep down, there's really no order to it. It's a set. It's like a collection of things. It's really used for math and in probability and statistics. A set is just a collection of items, and so it will not take duplicates. It's really nice for finding combinations, permutations, those kinds of things, intersections and unions. So if you're doing any kind of math, you might want to deal with sets. The really cool Python collection that I want to get into is called a dictionary. So let me define a dictionary about myself, called me, and I'm going to do some weird things here. First of all, it has curly braces like a set, but it's not a set. It's very different from a set. So I'm going to say first Bailey, that's my first name, comma, last colon Pulsey. Okay, you might be able to see the pattern. And then age, I'm not going to tell you my age. I'm just going to say 99. Okay, so me has 3 fields. Okay, these are called fields, or key value pairs, because this is the key, and then this is the value. So it's sort of like having a variable called first, and then a value called Bailey, and then a variable called last, a value called Hulsey, a variable called age, and a value called for a value of 99. But all of these things are wrapped up into a package called me. And I could make several dictionaries, one with each person in it. So that's really nice. For maybe a directory, if I have a staff directory or something for my organization. So in order to access those, the items in me, I cannot do index. I cannot use indices like this, index access, I guess you could say. I have to access it by the key. Okay, if I access it with the key, then it will tell me the value in that key. So I can access last, and that's Hulsey, and then if I access age, it would be 99. Notice how this is a integer, and these are strings. That's allowed. I can put anything in the value, but I have to have strings in the keys. So all your keys have to be strings, which will kind of slow you down, putting these quotation marks there. By the way, you could use double quotes as well. So that'll kind of slow you down. But it's very, very handy if you have some complex data going on, complex data structure. I could also change my age. I could update things right inside the dictionary if I wanted to. 95 instead, and then me looks like that. So you might notice that this up here is a list, actually, a list of strings. So dir returns a list of strings. When we did globals, that is actually a dictionary. So here's the key, and then here's the value. So a lot of these are names. That's a none. So that's a separate data type that we haven't really talked about. Look, this key is A, and then this value is the value of A. So all these variables that I've defined are the keys. The variable names are the keys, and the values are the values of the variables. Cool. And then this one, me is a key in this dictionary globals. And the value is another dictionary. So that kind of brings me into my next point. With dictionaries and with a lot of collection types in general, you can nest these sort of infinitely if you wanted to. You can have a incredibly complicated data structure. So I could have a dictionary called directory, and then in each directory, I have a key called, Mr. Holsey, and then Mr. Holsey, the value for that is all of my information. Then I could have another one called so and so else, another teacher's name, and then the value for that key is all of their information. Okay, so this can go on infinitely. So dictionaries are very, very powerful for storing a lot of complicated data with interlocking relationships.